Life history trade-offs. There are three life history tasks: reproduce, get resources, and survive. There are negative associations between life history characteristics and survivorship, which are referred to as trade-offs. In order to be successful, an organism compromises various developmental, physiological, and structural features. Moving requires a lot of energy, time, and equipment. This action takes away energy from reproduction. An example of the dispersal reproduction trade-off can be seen in the winged dimorphic cricket, Gryllus rubens. The cricket exists naturally as a fully winged morph, able to fly, or a short-winged morph, which cannot. The short-winged morph has a higher fecundity than the long-winged one, since it allocated more of its energy towards reproduction rather than the ability to fly. The allocation is a relationship between flight capability and fecundity. The short-winged morphs have vestigial flight muscles and have substantially more ovarian mass relative to the long-winged morphs. There is a physiological basis which is limited to the allocation of acquired and assimilated nutrients within the organism. Both short-wing and long-wing consume and digest the same amount of food, but in the adult stage, the long-winged morph is less efficient in converting nutrients into biomass due to respired loss of nutrients during the maintenance of functioning flight muscles. The cricket is therefore a perfect example of dispersal versus total reproduction trade-offs as seen in nature. Changes that increase growth often result in declines in reproduction and vice versa. Studies on the trade-offs between growth and reproduction and wild Atlantic cod have shown that these fish partition and trade off their resources between competing needs such as growth and reproduction depending on their environment. Studies have shown that there are distinct trade-offs between length growth and reproduction in the wild Atlantic cod. It has been observed that 6- and 7-year-old females who skipped spawning grew significantly more in the year of missed spawning than females spawning for the second consecutive year. This suggests that skip spawning may occur as an adaptive life history strategy given the potential future fecundity gain with increased size. It takes energy to reproduce, energy that the parent could be using to care for themselves, such as hunting, escaping predation, and self-repair. Raising altricial young adds to this reproduction cost. A recent study, which examined 44 species of long-lived seabirds, found that regardless of age and phylogeny, there were costs with brooding and raising young that significantly affected lifespan. Besides the simple energetics of reproduction and parental care, there are also situations that arose when raising young that increased risk of mortality. Offsprings are slow and awkward, often slowing the parent down. They also tend to get themselves into situations that require wasteful energy expenditure to get them out of trouble. There are many predators that specifically seek out eggs and young as easy, nutritious targets. Many parents put themselves in harm's way to protect their young, increasing their exposure to predators and to injury. In these ways, reproduction and survival are a trade-off event. Reproductive spouts are costly and require a large amount of energy. The cost of reproduction requires a trade-off, including a trade-off between present and future reproduction. This can be revealed by the relationship between the number of years without reproduction and reproductive investment within a reproductive year. Leatherback sea turtles are long-lived species with intermittent breeding, making them a great candidate for this study. A study modeled the breeding cycle in leatherbacks and estimated the reproductive effort according to the number of years elapsed since the last nesting season. The leatherback sea turtle's breeding cycle was found to be limited to 3 years. Individuals' reproductive effort who skipped one breeding season were compared to those who skipped 2 breeding seasons. The trade-off between current and future reproduction was found to exist in leatherbacks due to resource provisioning required to invest in reproduction. It's an advantage to have many offspring, but also to allocate more energy into fewer offspring so that they are larger and higher in fitness. However, the parents can only allocate so much energy towards their offspring, and therefore there is a trade-off between the number and size of offspring. This is demonstrated in sand lizards, which were caught just prior to oviposition in the wild and then compared to lab-raised lizards. Clutches of both groups were sampled, and a strong negative correlation between clutch size and offspring size was found. Wild females of bigger mass produced bigger but fewer offspring, and females who were small produced smaller but more offspring. Well-fed lab females laid bigger clutches but had smaller offspring. Overall, larger clutch sizes were consistently paired with smaller offspring for both wild and lab-raised lizards. This supports the idea that there is a limit on reproduction investment which is set by the resource availability. Throughout an organism's lifespan, trade-offs must be made in order to maximize fitness. These trade-offs are due to the principle of allocation. Since resources in any given environment are fixed, allocations must be partitioned in order to increase their chance of survival.